Okay, we'll look at a bilging problem, end of bilging. Could be forward or after end, it's the same principle. And we have a forward compartment, length 21, extending the full width of the vessel, and it has no watertight flat. So in this problem, we're looking at a vessel with no watertight flat. There's two methods to calculate the answer. I'll look at one of the methods now. So there's our sketch. 170 by 22 by 9.2 draft. The LCB, LCG obviously in line when the vessel isn't bilged, and what we have to calculate is the distance the LCB moves. I've marked 10.5 here, and we'll look at how we do that. You can see LCB there is the centre of the bilge compartment. The centre has to be 10.5 each way because this is a box shape that we've lost there, so that distance has to be 10.5. So always with the bilging problem you calculate the sinkage first. 21 by 22 by 9.2 will be the lost buoyancy, and hopefully you realise there, because the waterplane area is not intact, when we work out the intact waterplane we have to subtract this length off. So you can see I've written there 170 minus 21. So the new draft 10.497. Now to calculate the distance LCB moves aft from its original position, it creates a lever and trims the vessel. As the bilge compartment covers the whole depth, the remaining length or volume is symmetrical. So our distance from the original LCB to the new LCB will be half the length of the bilge compartment, 10.5. So the length of the compartment, half of that will be the distance the LCB moves. And to get the trimming moments created, then we multiply that by the displacement of the vessel, not forgetting the density to use. Now we've got the trimming moments, we need the MCTC, and there's the formula. Obviously weight doesn't change, length doesn't change. We need the GML, which is KML minus KG. The KG doesn't change, so KM is KB plus BM. Now because we've lost this portion here, this part is symmetrical, therefore the KB is simply the draft divided by 2. And then BL cubed over 12V. So it's the usual formula there. We get our GML. Once we've got that, we can get our MCTC and get our trim. And then the last point to mention is that because we've lost this part of the waterline, the longitudinal centre of flotation obviously moves as well. So if we subtract 21 from 170 and half that value, then we'll have the centre of flotation, and it's 74.5. Divide that by 170, multiply it by the trim, and we can find the change of trim aft. Subtract that from the total trim, that's the change of trim forward, and then we can write down our answers there. I've put there the new draft and the changes of trim. So that's one method of solving that problem, one of the two methods that we can use.